Okay, good morning, ladies and gentlemen. I would like to welcome you to my presentation, which is quantification of selected antioxidant compounds in sweet basil or Ocimum basilicum L through the optimization of temperature and solvent concentrations. Next slide, please. This is the outline of my presentation, which is starting from introduction and ending to references. Next, please. The scientific name of this plant is Ocimum basilicum L. This plant is belonging to Lamiaceae family. Sorry, it's belong to Lamiaceae family, and the local names in my language is Raihan, and sometimes it is called Nazebo. In Malaysia, it is called Selasi, and in India, it's called Jangli Tulsi. An English name is sweet basil. This plant is an annual warm season and sun-loving herbs. Sweet basil has antioxidant compounds such as phenolics and flavonoids. Due to this, it has a lot of pharmaceutical properties such as anti-cancer, antivirus, antifungal, and antiparasites. This herb is directly consumed in functional foods and medicines. Although sweet basil is rich in antioxidant compounds, yet the quantity of those compounds lies on the extraction technique. To justify this, the efficiency in extracting plants metabolites is depending on few factors, with temperature and concentration of solvent being the main contributor. Therefore, by optimizing temperature and solvent concentrations, optimum antioxidant compound will be extracted from sweet basil. This study was aimed to establish a suitable extraction technique through the optimization of different levels of temperature and concentrations of ethanol. Turning to literature review, we found that the main key factors are level of temperature and solvent concentration in extraction process. Besides of that, the efficient temperature for extracting phenolic compound was ranged from 40 to 90 degrees Celsius. And ethanol was found to be suitable solvent for extracting phenolics and flavonoid compounds. In this study, treatments were a combination of 3 levels of temperature, including 40, 60, and 80 degrees Celsius, which combined with 3 levels of ethanol, including 60, 70, and 90%. The experiment was organized in 2 factorial CRD with 4 applications and 3 samples per replicate. Parameters such as percentage of extraction yield, total phenolic content, total phenolic yield, total flavonoid content, total flavonoid yield, and antioxidant activity were investigated. During the extraction process, 10 grams of leaf powder was mixed with 100 ml of solvent and subjected to various level of temperatures and concentrations of ethanol. The extraction was performed using a water bath, and the mixture was subjected to filtration and then introduced to an Euler rotary evaporator to evaporate the solvent. After that, the dry extract was stored in minus 20 degrees Celsius for further investigations. Determination of total phenolic content was performed according to Foliant-Cioccolti assay. Determination of total flavonoid content was performed according to aluminum chloride assay, and determination of antioxidant activity was performed according to DPPH assay. The other parameters such as extraction yield, total phenolic yield, and total flavonoid yield were investigated using and were calculated using the formulas. Turning to results and discussion, you can see here in in the table figure number 1, the extraction yield was significantly affected by both factors. And here you can see there is a parallel increase by increasing the level of temperature from 40 degrees Celsius to 60 degrees Celsius and 80 degrees Celsius. Similarly, there is a parallel increase by in extraction yield by increasing concentration of Okay, sorry for the technical issue. Please go to slide 13, please. Please go to slide 13. Slide 13, please. Okay.
Yes, Dr. Hamid, you can start now.
Okay, which the best treatment for extracting optimum extraction yield is combination of 90% of ethanol at 80 degrees Celsius. Next slide, please. In case of total phenolic content, there is a significantly difference between all the treatments, and you can see that the higher content of total phenolic is belonging to combination of low concentration of ethanol at higher temperature, which is 60% ethanol at 80 degrees Celsius. But the lowest content of phenolic is belonging to low concentration of ethanol at low temperature. Next slide, please. In case of total phenolic yield, you can see almost the same trend is observed here. Here also, there is significantly differences between the treatments, and the higher yield of phenolic is belonging to combination of 60% ethanol at 80 degrees Celsius, and the lowest is belonging to low concentration of ethanol, which is 60% at low level of temperature, which is 40 degrees Celsius. Next slide, please. For total flavonoid content, you can see here there is significantly differences among the treatments, and among all treatments, the best treatment is recognized, which is combination of 60% ethanol at 80 degrees Celsius, which yields 44.70 milligram of quercetin equivalent per gram of dry extract. Next slide, please. Here, in case of total flavonoid yield, you can see almost the same trend is observed here. Here also, the best treatment is combination of 60% ethanol at 80 degrees Celsius, which yielded 462.52 milligram of quercetin equivalent per 100 gram of dry weight. Next slide, please. In case of antioxidant activity, there is also significantly differences between the treatments, and the antioxidant activity is affected by both factors. Here you can see higher antioxidant activity is at combination of 60% ethanol under 80 degrees Celsius. and the lowest is belonging to combination of 60% ethanol at both 40 degrees Celsius and also 60 degrees Celsius.